Close your eyes and imagine with me. A new world. A world where humanity has taken its first true steps beyond Earth, where the rust-colored dust beneath our feet tells stories billions of years old, and where every sunrise paints the sky in shades we never knew existed. Welcome to Mars. Welcome home. Your journey to this red world began months ago, though the memory feels like a dream now. The voyage from Earth took between 6 and 9 months, depending on the orbital alignment of the two planets. You spent that time in a spacecraft no larger than a small apartment, watching Earth shrink to a pale blue dot, then disappear entirely among the stars. During those long months, you grew accustomed to the silence of space, broken only by the gentle hum of life support systems and the quiet voices of your fellow travelers. And now you're here. As you step outside your habitat for the first time, the first thing you notice is how light you feel. On Mars, gravity is only about 38% of what you experienced on Earth. Each step feels almost like floating, like moving through water, as if the planet itself is gently cradling you. A backpack that weighed 50 pounds on Earth now feels like it weighs merely 19 pounds here. Your body will need time to adjust to this new lightness, this new way of being. You look up at the Martian sky and it's nothing like home. During the day, the sky glows a butterscotch yellow, sometimes deepening to a soft brown near the horizon. The thin atmosphere, made up of about 95% carbon dioxide, scatters light differently than Earth's nitrogen-oxygen blanket. Here, the sunset reverses everything you've ever known. While Earth's sunsets blaze red and orange, on Mars the sun sets in cool blues and purples, a twilight spectacle that feels almost otherworldly. Standing there in your pressurized suit, you watch as the sun, appearing only about 2/3 the size it does from Earth, dips below the horizon in a halo of sapphire light. Your new home is built partially underground, and for good reason. The Martian surface receives about 43% of the sunlight that Earth does, and without a thick atmosphere or magnetic field to protect you, radiation from space constantly bathes the landscape. Your habitat's walls, reinforced with Martian regolith, the iron-rich soil that gives Mars its distinctive color, provide crucial shielding. Above ground, transparent domes allow you to see the sky while specialized materials filter out harmful radiation, letting you live and work in relative safety. Time moves differently here in ways both subtle and profound. A Martian day, called a sol, lasts 24 hours and 39 minutes. Those extra 39 minutes might not seem like much, but over weeks and months, they create a gentle drift in your rhythm. Sleep schedules shift slightly each day. Meal times gradually wander. Your body's internal clock, tuned to Earth's 24-hour day for all of human evolution, must now adapt to this new planetary heartbeat. Some settlers wear special watches that track both Earth time and Mars time, though most eventually let go of Earth's rhythm entirely and surrender to the slower pulse of their new world. When you venture out to explore, you notice the landscape stretching endlessly in all directions. The horizon on Mars is much closer than on Earth, only about 3 kilometers away compared to 5 kilometers on Earth, due to Mars being a smaller planet with a diameter of about 4,200 miles, roughly half that of Earth. This creates an intimate feeling to the landscape, as if you're always walking through a series of vast rooms rather than across an infinite plain. Distant mountains seem closer, more present, more real. The seasons here are longer, stretched out like a slow breath. A Martian year lasts 687 Earth days, nearly twice as long as the year you left behind. Because Mars has a tilted axis similar to Earth's, about 25 degrees compared to Earth's 23.5, the planet experiences seasons much like home. But these seasons last almost twice as long. Winter lingers, spring unfolds slowly, summer becomes a marathon of warmth, and autumn drifts by like a meditation. If you arrive during northern spring, you won't see northern summer for nearly 6 months. Temperature is something you must respect on Mars with a careful attention. During a summer day at the equator, Temperatures might climb to a relatively pleasant 70 degrees Fahrenheit, almost comfortable. But as the sun sets and the thin atmosphere loses its grip on warmth, temperatures plummet dramatically. By midnight, that same spot might drop to -100 degrees Fahrenheit or even colder. Your habitat's heating systems work constantly, fighting against the cold that presses in from all sides. You learn to move between temperature-controlled spaces with care, always aware that Mars, for all its beauty, remains a fundamentally cold world. And then there's the dust. Mars is a dusty planet, and that dust is everywhere. The particles are incredibly fine, much finer than beach sand, with an average size of just 3 micrometers, smaller than a red blood cell. This dust clings to everything: your suit, your equipment, your boots. It works its way into seals and mechanisms. Early settlers learned that Martian dust is mildly toxic due to perchlorates in the soil, chemicals that are harmful if inhaled or ingested. Special airlocks and cleaning systems help keep the dust out of living spaces, and you develop routines for carefully cleaning your suit after every excursion outside, treating the rusty powder with a mix of respect and caution. As your first day on Mars draws to a close and you return to your habitat, sealing the airlock behind you, you realize something profound. You are living a dream that humanity has held for generations. You are proof that we can adapt, that we can thrive, that we can make a home among the stars. Tomorrow you'll explore further. You'll learn more about this strange and beautiful world. But tonight, you rest beneath an alien sky, knowing that you are exactly where you were meant to be. Morning comes quietly on Mars. The sun rises in the east just as it does on Earth, but here the dawn is a gradual brightening of that butterscotch sky, a slow warming of the darkness into light. You wake in your sleeping quarters, feeling strangely well-rested despite the planet's weaker gravity. Scientists have found that while muscles may atrophy over time in low gravity, many settlers report sleeping deeply here, their bodies cradled gently by Mars's lighter embrace. Your morning routine begins with water, and water on Mars is precious in ways it never was on Earth. Though the planet appears dry and desolate, Mars actually contains substantial water resources locked away in ice. The polar ice caps hold enough frozen water that if they melted completely, they could cover the entire Martian surface in liquid water about 35 feet deep. But this water isn't easily accessible. Your colony relies on mining ice from beneath the surface or extracting it from the polar regions, then melting and purifying it for use. Every shower is brief. Every drop is recycled. You've learned to think of water not as an endless resource, but as a gift to be cherished. After breakfast, you prepare for today's work outside. Your spacesuit is a marvel of engineering, but it's also a constant reminder of how hostile Mars can be. The atmospheric pressure on Mars is less than 1% of Earth's, about 0.6% to be precise. This means that without a pressurized suit, your blood would literally boil at body temperature, a process called ebullition. The suit maintains a comfortable pressure around your body, provides oxygen to breathe, and keeps you warm in the frigid Martian air. Putting it on is a ritual that takes about 20 minutes, checking every seal, every connection, every system. Your life depends on this shell of fabric and metal. Stepping outside, you're struck again by the stillness. Sound travels differently here in the thin atmosphere. Everything is muffled, quieter, as if the whole planet is wrapped in cotton. A shout carries only about 300 feet before fading to nothing, compared to over 1,000 feet on Earth. The silence is profound, almost meditative. You hear your own breathing inside your helmet, the soft hiss of your oxygen supply, the crunch of regolith beneath your boots, and little else. This is a quiet world, a world of whispers. Today's task takes you to the greenhouse domes, where humanity is learning to coax life from Martian soil. Growing food on Mars presents unique challenges, but it's essential for long-term survival. The Martian soil itself lacks the organic material and beneficial microorganisms found in Earth's soil, but it does contain many of the nutrients plants need: nitrogen, phosphorus, potassium. The problem is those perchlorates we mentioned, toxic chemicals that must be washed out before plants can grow safely. Inside the domes, carefully treated soil mixed with composted organic waste from the colony creates a growing medium where plants can thrive. Tomatoes, lettuce, potatoes, and herbs grow under LED lights that supplement the weak Martian sunlight filtering through the dome. As you work among the plants, you think about the strange geometry of this world. Mars is a smaller planet than Earth, with only about 28% of Earth's surface area. Yet interestingly, Mars has roughly the same amount of dry land as Earth does, because our home planet is 71% covered by oceans. This means that the explorable land area of Mars is comparable to all of Earth's continents combined. You could spend a lifetime walking across this world and never see it all, vast canyons, towering volcanoes, ancient impact craters, and plains that stretch beyond imagination. Speaking of volcanoes, you can actually see one from here on clear days. Olympus Mons, the largest volcano in the entire solar system, rises approximately 13.6 miles high, nearly 3 times the height of Mount Everest. It's so massive that if you stood on its summit, the peak would curve away beyond the horizon in every direction, and you wouldn't even realize you were on a mountain. The volcano is about 374 miles wide, roughly the size of the entire state of Arizona. It last erupted perhaps 25 million years ago, and it may not be completely dead. Standing on Mars, you're walking on a world that still holds geological secrets, a world that may yet have some fire left in its ancient heart. The work in the greenhouse takes several hours, and you notice something peculiar about time here. Not just the longer day, but the way activities must be carefully planned around dust storms. Mars is famous for its planet-wide dust storms that can last for months, blocking out the sun and coating everything in a fine layer of rust-colored powder. These storms typically occur during Martian spring and summer in the southern hemisphere, when Mars is closest to the sun in its elliptical orbit. During a major dust storm, solar panels lose efficiency, visibility drops to near zero, and outdoor activities become impossible. Your colony monitors weather patterns constantly, always prepared to shelter in place if a storm approaches. But Mars offers wonders that make all the challenges worthwhile. At night, when you emerge from the greenhouse, you look up to see 2 small moons racing across the sky. Phobos and Deimos, named after the Greek gods of fear and dread, are tiny compared to Earth's moon. Phobos is only about 14 miles across, and Deimos just 7.5 miles. Phobos orbits so close to Mars and moves so quickly that it rises in the west and sets in the east, appearing to move backward across the sky. It completes an orbit in just 7 hours and 39 minutes, meaning you can watch it rise and set multiple times in a single night. These irregular, potato-shaped moons are likely captured asteroids, ancient wanderers trapped by Mars's gravity eons ago. As evening approaches, you make your way to the colony's common area, a dome where settlers gather after the day's work. Here, looking out through the transparent ceiling at the darkening sky, you feel a sense of community that perhaps wouldn't exist on Earth. There are only a few hundred people in your colony, and every single one is essential. The population density on Mars is nearly zero, with all of humanity's settlements on Mars containing perhaps a few thousand people spread across a planet of 55 million square miles. You have more personal space per person than anywhere on Earth. Yet paradoxically, you feel closer to your fellow colonists than you ever felt to neighbors back home. Here you depend on each other absolutely. Every person's skills, every person's work, every person's presence matters in ways that create deep bonds. As you settle in for the evening, sharing a meal of greenhouse vegetables and protein rations with your companions, you realize something profound. Life on Mars is not easy. It demands constant attention, constant care, constant respect for the environment. But it's also teaching humanity something important: how to live more intentionally, how to value resources, how to work together toward common survival. Tomorrow will bring new challenges and new discoveries. But tonight, you're simply grateful to be alive, to be here, to be part of this grand adventure. Another soul begins, and you're starting to feel the rhythm of this place settling into your bones. Today is special. You'll be venturing farther from the colony than ever before, exploring one of Mars's most remarkable features. But first, your morning medical check. Living on Mars requires constant monitoring of your health, because the environment affects your body in subtle and profound ways. The medical officer reviews your bone density scans. In Mars's low gravity, your bones don't bear as much weight as they did on Earth, and without the constant stress of full gravity, they begin to lose density, about 1 to 2% per month. This is one of the most serious challenges of long-term Mars habitation. To combat this, you spend 2 hours every day in the exercise facility, working out with resistance bands and weights, running on treadmills with harnesses that pull you down, simulating heavier gravity. Some colonists take medication to help maintain bone strength. Everyone consumes a carefully designed diet rich in calcium and vitamin D, synthesized here on Mars since there's little natural sunlight to produce it in your skin. After your checkup, you join an expedition team heading to Valles Marineris, a canyon system so vast it defies comprehension. This enormous scar across Mars's face stretches approximately 2,500 miles long, nearly the width of the entire United States. It's up to 125 miles wide in places and plunges 23,000 feet deep, making it about 4 times deeper than the Grand Canyon. Scientists believe it formed billions of years ago as Mars's volcanic Tharsis region bulged upward, cracking the crust like dried mud. Standing at its edge is like standing at the edge of a continent, looking down into layers of geological history written in stone. The rover journey takes hours and you watch the landscape transform slowly around you. Mars is an ancient world, much older in its geological inactivity than Earth. While Earth's surface is constantly renewed by plate tectonics, creating new crust and recycling old, Mars's tectonic activity appears to have ceased billions of years ago. The rocks you're driving past, the craters you're skirting, the formations you're observing, many of them have remained virtually unchanged for 3 to 4 billion years. You're looking at a frozen moment in planetary history, a world that stopped evolving geologically long before complex life emerged on Earth. As you travel, dust devils appear in the distance, thin columns of swirling rust-colored dust spiraling upward into the sky. These whirlwinds are common on Mars, often growing much larger than their Earth counterparts. Some reach heights of up to 12 miles tall, far taller than any tornado on Earth. Despite their impressive size, they're far less dangerous than they appear. The thin atmosphere means there's very little actual force behind the wind. A Martian dust devil with winds of 60 miles per hour would exert only about the same pressure as a 5-mile-per-hour breeze on Earth. Still, they're mesmerizing to watch, these ghostly dancers moving across the ancient plains. The rover's communication system crackles to life. Its mission control back at the main colony. Communication with them has a noticeable delay. Your signal takes between 3 and 22 minutes to reach Earth, depending on where the two planets are in their orbits. When Mars and Earth are on opposite sides of the Sun, messages take over 40 minutes round trip. This means real-time conversation with people back home is impossible. Instead, you've learned to send long video messages, telling stories about your day, sharing your experiences, and then waiting patiently for responses that arrive like letters from another century. It's made you more thoughtful about communication, more intentional with your words. You arrive at a research site where scientists are studying ancient riverbeds. Yes, riverbeds, channels carved by water that flowed here billions of years ago. Evidence suggests that Mars was once a very different world. Around 3.5 to 4 billion years ago, Mars likely had liquid water flowing on its surface, carving valleys, filling lakes, possibly even creating a northern ocean. The atmosphere was thicker then, warm enough and dense enough to support liquid water. But Mars, being a smaller planet with only about 11% of Earth's mass, couldn't hold onto that atmosphere. Its weaker gravity allowed atmospheric gases to gradually escape into space, and without a strong magnetic field to protect it from solar wind, that escape accelerated. The Mars you see today is a ghost of what it once was. Your team collects samples from the ancient riverbed, carefully storing them in sealed containers. There's a chance, remote but tantalizing, that these rocks might contain evidence of ancient microbial life. If Mars once had liquid water, a thicker atmosphere, and a warmer climate, it's possible that life emerged here just as it did on Earth. No definitive proof has been found yet, but the search continues. Every sample analyzed, every rock studied brings humanity closer to answering one of our deepest questions. Are we alone? The very soil beneath your boots might hold the answer. As you work, you notice how clear everything appears. Mars has no ozone layer like Earth does, which means the already thin atmosphere provides virtually no protection from ultraviolet radiation. UV levels on the surface are about 30 to 40% higher than on Earth. This is another reason why habitats are built with radiation shielding and why your suit includes UV-blocking materials. Over time, unprotected exposure would damage your DNA, increasing cancer risk dramatically. But this lack of atmospheric filtering also means that when you look at the stars at night, they shine with a brilliance you never saw through Earth's thick blanket of air. The work takes most of the day, and as the sun begins its descent toward the horizon, you're reminded of another peculiar feature of Mars. The planet's orbit around the sun is noticeably elliptical, more oval-shaped than Earth's nearly circular orbit. At its closest approach to the sun, called perihelion, Mars is about 129 million miles away. At its farthest point, aphelion, it's about 154 million miles distant. This 25 million mile difference means that Mars receives about 40% more solar energy during southern summer than during southern winter. These orbital variations contribute to Mars's extreme seasonal weather patterns and are part of what makes predicting dust storms so important for colony planning. As your rover begins the journey back to the colony, the sun sets behind you in those incredible blues and purples, and the first stars begin to appear. You can see Earth in the evening sky, a bright blue star brighter than any other. From here, Earth and its moon appear as a double star system, close together but distinct. You think about everyone you left behind, living their lives 140 million miles away on that blue dot. You wonder what they're doing, whether they're looking up at the night sky, whether they're thinking of you. The distance feels vast and intimate all at once. You are so far from home, yet you carry home with you in every memory, every breath, every dream. Tomorrow there will be more work to do. But tonight, as the stars wheel overhead and Mars's little moons race across the sky, you simply exist in this moment, this place, this extraordinary gift of being alive on another world. The colony is quiet this morning. It's rest day, a day when non-essential work pauses and people take time to simply be. Even on Mars, even in a place where survival demands constant attention, humanity has learned that rest is not a luxury but a necessity. You wake slowly, without alarm, and for a few peaceful moments, you simply lie there, feeling the gentle pull of Martian gravity, listening to the soft hum of air recyclers that have become as familiar as breathing. You make your way to the observation lounge, where large windows offer a panoramic view of the Martian landscape. Today the sky has a reddish tint to it. There's dust in the upper atmosphere, particles suspended high above the surface. These dust particles are rich in iron oxide, essentially rust, which is why Mars earned its nickname, the Red Planet. Everything here is tinged with iron. The soil, the rocks, the dust that coats every surface. In fact, the Martian regolith contains about 16% iron by weight, compared to Earth's average of about 5%. You're living on a world made of rust, a planet that oxidized billions of years ago and now wears its age like a badge of honor. Someone has made coffee, real coffee from beans grown in the greenhouse. It's a luxury, a precious reminder of Earth. As you sip it slowly, savoring every drop, you chat with other colonists about their plans for the day. One scientist mentions she'll be studying the magnetic field data. Mars lost its global magnetic field about 4 billion years ago when its molten core cooled and solidified, though some regions of the crust still retain localized magnetic fields from that ancient time. These magnetic fossils in the rocks tell the story of a planet that once had protection from solar radiation, a shield that Earth still enjoys. Without that protection, Mars's atmosphere was gradually stripped away by solar wind over millions of years. After breakfast, you decide to visit the colony's library, a small room filled with digital archives and a few precious physical books brought from Earth. You select a book on planetary science and settle into a comfortable chair. Reading about Mars while living on Mars creates a strange doubling effect, as if you're existing in two places at once. You learn that the planet's distinctive red color would have been even more apparent to ancient astronomers. Mars can appear remarkably bright in Earth's night sky. At its closest approach to Earth, it can shine with a magnitude of -2.9, making it one of the brightest objects visible from Earth after the Sun, the Moon, and Venus. Ancient cultures around the world named it after their gods of war, struck by its blood-red appearance. As the day progresses, you join a group exploring one of the lava tubes discovered near the colony. These natural tunnels, formed billions of years ago when flowing lava created channels beneath the cooling surface, are some of the most exciting features for future colonization. Martian lava tubes can be enormous. Some are estimated to be up to 800 feet wide and several miles long, far larger than any found on Earth because of Mars's lower gravity allowing larger geological structures to form without collapsing. Inside these tubes, you're protected from radiation, from temperature extremes, from dust storms. Many believe that future Mars cities will be built within these natural shelters, entire communities living in the ancient veins of volcanic activity. The tube you're exploring opens into a vast chamber, and your helmet lights barely reach the ceiling. The silence here is absolute, more profound than anywhere else on Mars. You're standing in a space untouched by wind or weather, unchanged since it formed when lava last flowed here perhaps 100 to 200 million years ago. The air in your suit hisses softly, but beyond that, nothing. No echo returns when you speak. The thin atmosphere that exists outside doesn't penetrate this deep. You're in a vacuum, essentially, standing in a natural cathedral carved by ancient fire. Back at the colony, evening brings the weekly video message from Earth. The transmission arrived hours ago, but everyone gathers to watch it together. You see faces of family members, friends, mission controllers, all speaking to you across the void. They tell you about seasons changing on Earth, about children growing, about daily life continuing in your absence. The average distance between Earth and Mars is about 140 million miles, though this varies from about 34 million miles at closest approach to 250 million miles when the planets are on opposite sides of the Sun. Right now you're somewhere in between, but the distance feels infinite and paper-thin all at once. After the video ends, you volunteer for a shift in the power management center. Energy is carefully rationed on Mars, with solar panels providing most of the colony's power during daylight hours. The solar panels here are less efficient than on Earth because of the dust that constantly settles on them and because Mars receives only about 590 watts of solar energy per square meter at noon, compared to Earth's 1000 watts. The panels must be cleaned regularly, and battery systems store energy for the long Martian night. During major dust storms, when sunlight is blocked for weeks or even months, the colony relies on a small nuclear reactor, a backup power source that hums constantly in its shielded bunker, a reminder that human life here depends on technology working perfectly every single day. As your shift ends, you step outside briefly to watch the night sky. Mars has no light pollution, no atmospheric distortion beyond the thin veil of carbon dioxide. The stars are so numerous they form a solid carpet of light, the Milky Way stretching overhead like a river of diamonds. You can see the Andromeda galaxy with your naked eye, a smudge of light containing 1 trillion stars. From this vantage point, the universe feels both impossibly vast and intimately close. You notice something moving across the sky, a satellite, one of the many that orbit Mars now, providing communication, navigation, and monitoring services for the growing human presence here. Mars's orbit is now home to dozens of these artificial moons, remnants of past missions and active infrastructure for current ones. The orbital period for a satellite at Mars's equivalent of Earth's geostationary orbit would be about 20 hours, but because of the planet's rotation rate, a true geostationary orbit isn't practical. Instead, satellites use a variety of orbits, some polar, some equatorial, all working together to keep the colonies connected to each other and to Earth. As you return inside and prepare for sleep, you think about how quickly this place has become normal. The red dust, the butterscotch sky, the lighter gravity, the 2 small moons, all of it feels like home now. You've adapted, as humans always do, finding comfort in the routines and rhythms of this alien world. Tomorrow you'll work in the fabrication lab, using 3D printers to manufacture replacement parts from Martian materials. The next day, perhaps a long rover journey to collect ice samples. The day after that, who knows? But tonight, you sleep peacefully under the stars of a distant world, dreaming dreams that span the space between planets, between what was and what will be. Morning light filters through your window with that familiar golden hue, and you rise to begin another day. Today is marked on the calendar as a special occasion. It's been exactly 1 Martian year since the colony was established. 687 Earth days have passed, though it feels both longer and shorter than that. Time has a way of blurring here, stretching and compressing like the light that bends through the thin atmosphere. At breakfast, there's a celebratory mood. Someone has baked bread, a rare treat made from wheat grown in the greenhouse. As you eat, a geologist excitedly shares news about recent seismic readings. Mars does experience Marsquakes, though they're generally much weaker than earthquakes. The largest recorded Marsquakes have been around magnitude 5, compared to the catastrophic magnitude 9 earthquakes possible on Earth. These quakes are caused by the slow cooling and contraction of the planet's interior, creating stresses that occasionally release. The seismic data helps scientists understand what lies beneath the surface. The thickness of the crust, the size of the core, the structure of this ancient world's interior. After breakfast, you suit up for a survey mission to an area where ice has been detected just beneath the surface. Water ice on Mars exists in many forms, not just in the polar caps, but buried under layers of regolith across much of the planet, especially at higher latitudes. In some regions, this ice begins just inches below the surface. The ice is mixed with soil in what's called permafrost, frozen solid in the perpetual cold. Finding and extracting this ice is crucial for colony sustainability, providing water for drinking, for growing food, and for producing oxygen and rocket fuel through electrolysis. The rover carries you across terrain sculpted by ancient processes. You pass by polygonal patterns in the ground, geometric cracks that form when ice beneath the surface expands and contracts with temperature changes, creating shapes that look almost artificial, like tiles laid by some cosmic mason. These patterns are remarkably similar to those found in Arctic regions on Earth, evidence that despite their differences, both worlds follow the same physical laws, the same patterns emerging wherever ice and soil interact over time. Your destination is a crater about 2 miles wide. Impact craters cover Mars, scars from billions of years of cosmic bombardment. The Martian atmosphere is too thin to burn up most meteorites the way Earth's thick atmosphere does, so objects that would disintegrate harmlessly over Earth often reach Mars's surface intact. Large impacts still occur occasionally. Scientists estimate that meteorites large enough to create craters several feet across strike Mars about once per month somewhere on the planet. The crater you're visiting is much older, perhaps hundreds of millions of years, its rim softened by eons of dust deposition and erosion from wind. As you work, deploying instruments to measure subsurface ice content, you notice how the temperature is changing. Even over the course of a few hours, temperature swings on Mars can be dramatic. The thin atmosphere has very little thermal mass. It can't hold heat the way Earth's thick atmosphere does. You might experience a 100-degree Fahrenheit temperature change between the warmest part of the day and the coldest part of night. Right now, in midday sun, your suit's external thermometer reads a relatively balmy 32 degrees Fahrenheit. By midnight, this same spot might drop to minus 80 degrees or colder. A dust devil swirls past in the distance, and you watch it dance across the plain. These vortices are driven by solar heating. Sunlight warms the ground, which warms the air above it, creating convection currents in the thin atmosphere. The dust devils you see on Mars are visible only because they pick up the fine rust-colored dust. The wind itself is nearly invisible, much weaker in force than comparable winds on Earth. Wind speeds on Mars can reach 60 miles per hour or more during storms, but because the atmosphere is so thin, these winds exert very little force. A 60-mile-per-hour wind on Mars produces about the same pressure as a gentle 6-mile-per-hour breeze on Earth. Your communicator crackles with a message from the colony. There's news from one of the polar research stations. They've measured the thickness of the northern ice cap using ground-penetrating radar. The results show that Mars's north polar ice cap contains layers of water ice and dust that extend down about 1.2 miles at its deepest point. These layers are like pages in a history book, each one representing a different climate epoch in Mars's past. The planet's axial tilt varies much more dramatically than Earth's over long periods, causing major climate shifts. Sometimes Mars tilts as much as 60 degrees, which would create dramatically different seasons than the current 25-degree tilt produces. As you complete your survey and begin the journey back, you pass through an area of sand dunes. Martian sand dunes are fascinating features, shaped by winds that blow consistently in certain directions over thousands of years. Some of these dunes are enormous. The largest can be several hundred feet tall and stretch for miles. The sand itself is darker than the surrounding dust, made of particles ground down from volcanic rocks. In certain seasons, you can actually watch these dunes move, shifting grain by grain across the landscape, migrating at rates of a few feet per year. Mars may seem frozen and dead, but it's still a dynamic world, still changing, still alive in its own slow way. Back at the colony, the afternoon is dedicated to maintenance. Every system requires constant attention. Air recyclers, water purifiers, power systems, communication arrays. You work alongside an engineer who explains that one of the biggest challenges is dealing with the regolith's electrostatic properties. The fine Martian dust carries an electric charge due to friction and UV radiation, causing it to stick to surfaces with surprising tenacity. This charged dust can interfere with mechanical systems, coat solar panels, work its way into seals and joints. On Earth, dust settles with gravity. On Mars, dust clings actively, almost as if it's seeking out places to lodge itself. As evening approaches and you wash up for dinner, you catch sight of yourself in a mirror. You look different than you did when you arrived. Leaner, perhaps, your face slightly changed by months in lower gravity. But your eyes hold something new too. A depth, a perspective that comes from standing on another world and looking back at the fragile blue marble where humanity began. Tonight, the colony will celebrate its one-year anniversary with a communal meal, sharing stories and songs, remembering why you all came here and dreaming about what the next year will bring. More colonists are scheduled to arrive in the coming months. The greenhouse is expanding. New habitats are under construction. This outpost is becoming a settlement, and that settlement is becoming something more, a home. You think about the children who might one day be born here, who will grow up knowing Mars as their native world, who will look at Earth as a distant place they've only seen in pictures. They will be the first generation of Martians, and they will carry humanity forward into a future we can barely imagine. But that's tomorrow's story. Tonight, you celebrate simply being here, being alive, being part of something larger than yourself. A new soul dawns, and with it comes anticipation. Word has spread through the colony that conditions are perfect today for a journey to one of Mars's most intriguing features, recurring sloped lineae. These dark streaks appear on certain slopes during warm seasons and have puzzled scientists for years. Some believe they might be evidence of liquid water, however brief and briny, flowing on the Martian surface even today. As you prepare for the expedition, a botanist stops by to show you something remarkable. She holds a small container with a tiny green plant, a mustard seedling that germinated in pure Martian regolith after the perchlorates were washed out. It's a simple thing, this small plant, but it represents something profound. Mars's day length of 24 hours and 39 minutes turns out to be nearly ideal for Earth plants. Their circadian rhythms, evolved over billions of years under Earth's 24-hour day, adapt remarkably well to the slightly longer Martian sol. The plants seem to thrive on this schedule, their leaves opening and closing, their growth patterns steady and strong. Life from Earth finding a way to grow in Martian soil. The expedition team assembles and you set out across the rust-colored plains. Your destination is about 30 miles away, a journey that will take several hours. Along the way, your guide points out features in the landscape: ancient riverbeds, dried delta formations, terraces that mark different water levels from billions of years ago. The evidence of Mars's watery past is everywhere once you learn to read it. Scientists estimate that ancient Mars may have held as much water as Earth's Arctic Ocean, perhaps enough to cover the entire planet in a layer 450 feet deep. Where did all that water go? Some escaped to space, some is locked in the polar ice caps, and much of it is believed to be frozen in the ground as permafrost, waiting beneath your wheels. As you travel, you notice the peculiar way shadows fall on Mars. The sunlight here, filtering through the thin atmosphere, creates shadows that are softer than on Earth but also stranger. Because there's less atmospheric scattering, the contrast between light and shadow is sharper in some ways. Objects in shadow appear darker, more defined. Yet because the sky itself glows with that butterscotch light, some light reflects into shadowed areas, creating an unusual quality, a dreamlike illumination that photographers back on Earth would struggle to capture or believe. You arrive at the site of the recurring slope lineae just as the sun reaches its zenith. These dark streaks run down steep slopes, appearing during warm seasons and fading during cold ones. They're narrow, typically less than 16 feet wide, but can extend hundreds of feet down slopes. The leading theory is that they're caused by seasonal melting of subsurface ice or the flow of very briny water, which can remain liquid at temperatures where pure water would freeze. Salt concentrations in the Martian soil can create brines that stay liquid even at -70 degrees Fahrenheit. If this is flowing water, even temporarily, it would be one of the most significant discoveries in the search for present-day habitable conditions on Mars. While the team sets up monitoring equipment, you take a moment to simply observe the landscape. Mars's sky creates unusual optical effects. The sun appears about 2/3 the size it does from Earth, subtending an angle of about 21 arc-minutes compared to Earth's 32 arc-minutes. This smaller sun, combined with the thin atmosphere, means sunsets last only about 2/3 as long as on Earth. When the sun dips below the horizon, darkness falls relatively quickly. There's less atmosphere to scatter the light and create the long, lingering twilight that Earth enjoys. The transition from day to night feels more abrupt, more definitive. During lunch, eaten inside the pressurized rover, a geochemist shares data about the unusual mineral formations nearby. Mars has some minerals that are rare on Earth but common here, and others that Earth has in abundance but Mars does not. One fascinating example is a mineral called jarosite, an iron sulfate compound that requires water to form. Finding jarosite on Mars is considered strong evidence that liquid water once existed in that location. The planet is full of these mineral clues, each one a piece of evidence in the detective story of Mars's past, helping scientists reconstruct what this world was like when it was young and wet and perhaps alive. As afternoon settles in, you notice Phobos rising in the west, that strange, backward motion that never stops being surreal. Phobos is gradually spiraling closer to Mars, falling about 6 feet toward the planet every century due to tidal forces. In approximately 50 million years, it will either crash into Mars or, more likely, be torn apart by tidal forces when it crosses the Roche limit, creating a ring system around the planet. Future Martians, millions of years from now, will look up and see rings circling their world, rings made from the shattered remains of this small moon that now races overhead. The monitoring equipment has been recording data all day, and now it's time to head back. As you begin the return journey, the sky starts to take on that evening glow. You pass by an area where the ground appears to shimmer slightly. This is where morning frost had accumulated and sublimated during the day. Mars has a water cycle, though it's nothing like Earth's. During winter, water vapor in the atmosphere freezes out and falls as frost, accumulating on the ground and on slopes facing away from the sun. As temperatures rise during the day, this frost doesn't melt. Remember, the atmospheric pressure is too low for liquid water to exist. Instead, it sublimates, turning directly from ice to vapor like dry ice on Earth. This daily cycle of freezing and sublimation slowly shapes the landscape over eons. As darkness approaches and you're still an hour from the colony, the stars begin to emerge. Without city lights, without atmospheric haze, the night sky on Mars is breathtaking. You can see stars that would be invisible from most places on Earth. The zodiacal light, a faint glow caused by dust in the solar system reflecting sunlight, is clearly visible, something only observable from the darkest locations on Earth. You spot Mars's outer moon, Deimos, a tiny point of light moving slowly across the stars. Unlike Phobos with its rapid transit, Deimos takes about 30 hours to orbit Mars, meaning it stays above the horizon for roughly 2.7 sols before setting. It would be easy to miss if you weren't looking for it, just a faint star among thousands. You arrive back at the colony as the last light fades from the sky. The habitat lights glow warmly through the transparent domes, a beacon of human presence in the Martian night. Inside, people are gathered around a large display screen, watching footage from Earth. A forest in autumn, leaves turning gold and red, a river flowing swift and clear. Someone has tears in their eyes. The beauty of Earth, seen from this distance, from this alien world, carries a weight it never had when you lived there. You took it for granted then, the blue sky, the abundant water, the ease of simply walking outside and breathing. Now you know how precious it all was. How precious it remains. But you also know something else. As you look around at your fellow colonists, at the plants growing in the greenhouse, at the maps on the walls showing future expansion plans, you realize that humanity is no longer confined to one world. We are becoming something new, a species that lives among the stars, that makes homes on distant planets, that carries the light of consciousness farther into the cosmos with each passing year. Tonight, you sleep knowing that both worlds, Earth and Mars, are part of who you are now. You are a bridge between planets, a link in a chain that stretches from the past into a future we're still creating, one soul at a time. You wake to an unusual sight through your window. The sky has taken on a deeper, more orange hue than usual. There's a dust storm building somewhere over the horizon, nothing major, but enough to change the quality of light filtering through the atmosphere. These regional dust storms are part of Mars's rhythm, occurring somewhere on the planet almost constantly. Unlike the planet-encircling storms that happen every few Martian years, these smaller storms are manageable, just another weather pattern to track and respect. At breakfast, there's excited chatter about a new arrival. The colony has received a shipment from Earth, delivered by an autonomous cargo lander that touched down perfectly in the designated landing zone. Among the supplies are fresh seeds, new equipment, and most precious of all, letters and small packages from loved ones back home. The journey these packages made is extraordinary. They were loaded onto a spacecraft during Earth's launch window, a period that opens only once every 26 months when Earth and Mars are properly aligned for efficient travel. Missing that window means waiting over 2 years for the next opportunity, making every launch from Earth a carefully orchestrated event years in the planning. You spend the morning helping to unload the cargo. Among the supplies are specialized parts for the colony's 3D printers, which can manufacture tools and components from Martian raw materials. One of the most valuable resources for manufacturing is actually Mars's atmosphere itself. That thin envelope of carbon dioxide can be processed to create useful materials. Through a process called the Sabatier reaction, atmospheric CO2 can be combined with hydrogen to produce methane and water. The methane can be used as rocket fuel for return trips to Earth, while the water supports life and can be split into hydrogen and oxygen. This ability to create resources from the Martian environment is called in situ resource utilization, or ISRU, and it's the key to making Mars colonization sustainable. After the unloading is complete, you're assigned to a geological survey team heading to an area rich in olivine, a green mineral that's common on Mars. Olivine is particularly interesting because it reacts with water, and its presence or absence tells scientists about the watery history of different regions. Areas rich in olivine likely saw little water, while areas where olivine has weathered away suggest prolonged water exposure. The Martian crust contains different minerals at different depths. The top layer of regolith and dust, then beneath that, bedrock of volcanic basalt, and deeper still, the ancient primordial crust that formed when Mars was young. Each layer is a chapter in the planet's geological autobiography. The survey takes you near an impact crater that's relatively young by Martian standards, perhaps only 10 million years old. The crater's rim is still sharp and well-defined, not yet worn down by eons of wind erosion. Looking at this crater, you're reminded of an interesting fact. Mars has about 1/3 the surface gravity of Earth, which means that when meteorites strike Mars, they create larger craters than equivalent impacts would produce on Earth. A meteorite traveling at the same speed will penetrate deeper and excavate more material on Mars because there's less gravity pulling it back. This is why Mars's surface is so heavily cratered, not just because the thin atmosphere lets more objects through, but because each impact leaves a bigger scar. During lunch, sitting on an outcrop of ancient rock, you gaze toward the horizon. The Martian horizon is closer than Earth's, creating an intimate feeling to the landscape, but it also means you can see the curvature of the planet more easily. Mars has a circumference of about 13,300 miles around its equator, roughly the distance from New York to Tokyo on Earth. It would take a long time to walk around Mars, but theoretically you could. No oceans block your path. Every square mile of Martian surface is potentially accessible, a whole world of rust-red deserts, ancient volcanoes, deep canyons, and polar ice caps waiting to be explored. As you continue your survey, you notice patterns in the rock formations, layers upon layers of sedimentary deposits laid down over millions of years. Some of these layers contain clay minerals, which form in the presence of water and neutral pH conditions. The discovery of widespread clay deposits on Mars revolutionized our understanding of the planet's past. These clays suggest that ancient Mars wasn't just wet. It had relatively mild water, not too acidic, not too alkaline, the kind of water that could potentially support life. Different regions show different types of clay, indicating that Mars had diverse aqueous environments. Lakes, rivers, perhaps seas, each with its own chemistry, its own story. Your communicator chirps. Mission Control wants you to collect samples from a particular outcrop that orbital surveys have identified as promising. As you carefully extract rock cores and seal them in sterile containers, you think about how much we've learned about Mars from orbit. Multiple spacecraft have been mapping Mars for decades now, using instruments that can see in wavelengths invisible to human eyes, infrared, ultraviolet, radar wavelengths that penetrate beneath the surface. These orbital surveys revealed that beneath Mars's southern highlands lies what may be a lake of liquid water, kept from freezing by pressure, salts, and possibly geothermal heat. If this subsurface lake exists, it would be about 12 miles across, lying beneath nearly a mile of ice. It might be one of the most intriguing targets for future exploration. The wind picks up slightly as afternoon progresses. You can see it stirring the dust into small swirls and patterns. Wind on Mars, despite being so much weaker in force than Earth winds, is incredibly effective at moving dust over geological timescales. The planet's entire surface is covered in a layer of dust that's been transported and redistributed by wind for billions of years. Some dust particles on Mars may have been blown around the planet multiple times, traveling thousands of miles, slowly abrading and breaking down into ever finer particles. This dust is so fine that it remains suspended in the atmosphere for months after being lifted by storms, giving the Martian sky its characteristic color. As you begin the journey back to the colony, the sun starts its descent toward the horizon. You notice something peculiar. Earth is visible in the evening sky, but Venus is even brighter. From Mars, Venus shines as the brightest object in the sky besides the Sun and the two Martian moons. Earth appears as a blue star, easily visible but not as dramatically bright as Venus. Looking at both planets, Venus wrapped in its crushing atmosphere and runaway greenhouse effect, Earth with its perfect balance of conditions for life, you're reminded of how rare and precious habitable conditions really are. Mars sits between these extremes, a world that was once more Earth-like but lost its atmosphere, a cautionary tale and a challenge all at once. You arrive back at the colony as the first stars appear. Inside, there's a gathering in the common area. Someone has received a video message from Earth containing particularly good news, and they want to share it with everyone. As you join the group, you're struck by the sense of community here. Every person in this room chose to leave everything they knew, to travel farther from home than any humans in history, to live on a world where the sky is the wrong color and the gravity feels strange and every breath comes from a machine. Yet here you are, laughing together, sharing stories, celebrating small victories. Humanity adapting, surviving, thriving even in the most unlikely of places. Tomorrow will bring new challenges, equipment that needs repair, experiments to conduct, resources to gather, systems to maintain. But it will also bring new discoveries, new wonders, new moments of beauty found in the most unexpected places. For now, as the Martian night deepens and Phobos races overhead in its backward dance, you feel something rare and precious, contentment. You are exactly where you're meant to be, doing exactly what you were meant to do, part of humanity's greatest adventure. Today begins with something different, a medical checkup focusing on your vision. Living on Mars has subtle effects on the human body that scientists are still documenting, and one of the most interesting involves the eyes. In the lower gravity and slightly different pressure environment, some colonists experience changes in their vision over time. The shape of the eyeball can subtly shift, and the optic nerve can experience slight changes in pressure. Regular monitoring helps doctors track these changes and adjust treatment as needed. It's a reminder that humans evolved for Earth-specific conditions, and every aspect of Mars, from its gravity to its atmosphere to its radiation environment, requires our bodies to adapt in ways both visible and invisible. After your checkup, you head to the agricultural center for your weekly shift. The greenhouse domes have expanded significantly since you arrived, and now include a section dedicated to experimental crops. One of the most successful has been potatoes, which thrive in Martian conditions once the soil is properly treated. Potatoes are efficient, nutritious, and psychologically important. They're familiar, comforting, a taste of Earth. The agricultural team has calculated that Mars could theoretically support large-scale farming in the future. With sufficient greenhouse space and proper soil treatment, an area of about 200 square meters of growing space could support one person's complete nutritional needs, though this requires significant energy input for lighting, heating, and maintaining proper atmospheric conditions inside the growing spaces. While tending to the plants, you learn something fascinating from a botanist. The seeds that grow here are already beginning to show subtle adaptations to Martian conditions. Plants grown from seeds that were germinated and harvested on Mars seem to adjust more quickly to the day-night cycle and show slightly different growth patterns than the original Earth seeds. It's evolution happening in real time, life finding ways to adapt to this new world. These second-generation Martian plants might one day be genuinely distinct from their Earth ancestors, the first truly Martian life forms beyond microbes, if any ancient Martian microbes ever existed. Your afternoon assignment takes you to the robotics bay, where autonomous rovers and drones are maintained. These machines are essential to colony operations, venturing out to perform surveys, collect samples, and monitor distant equipment when human presence isn't required or would be too risky. The rovers here are much more sophisticated than the early exploration rovers that first mapped Mars. They can operate independently for weeks at a time, making decisions about navigation and sample collection using artificial intelligence trained on years of Martian data. Some rovers have been continuously operating for over 5 Earth years on Mars, traveling hundreds of miles, their solar panels regularly cleaned by passing dust devils that, ironically, help as much as they harm. While performing maintenance on a rover's wheel assembly, a technician points out the wear patterns. The Martian regolith is abrasive, all that iron oxide, those fine particles, act like sandpaper on moving parts. The wheels show grooves and scratches from thousands of miles of travel across rock and dust. Engineers have learned to design equipment specifically for Martian conditions, using materials that can withstand the abrasive dust, the extreme temperature swings, and the oxidizing environment. Every mission to Mars teaches lessons that improve the next generation of equipment, each iteration more durable and efficient than the last. As you work, news comes through from one of the orbital satellites. A new crater has been detected, formed by a meteorite impact that occurred within the past few months. The impact was large enough to be detected from orbit, creating a crater about 50 feet across. Studying fresh craters helps scientists understand impact processes and also reveals fresh subsurface material excavated by the impact. These new craters appear on Mars at a rate of about 200 per year across the entire planet that are large enough to be detected from orbit. Each one is an opportunity to study what lies beneath the surface, to see layers of geological history exposed in an instant by the violent arrival of space rock. Your shift ends as the sun begins its descent, and you decide to take a walk around the colony perimeter. The habitat modules are connected by pressurized tunnels, but there's also an external path where you can walk in your suit, feeling more directly connected to the Martian surface. As you walk, you notice how the lengthening shadows create dramatic contrasts across the landscape. The way light behaves on Mars still fascinates you. The sunset colors are beginning to paint the sky in those signature blues and purples, while the ground takes on a deeper, richer red in the slanting light. You pause at a memorial marker, a simple plaque embedded in a large rock. It commemorates the first settlers who didn't survive, the pioneers who gave their lives so that humanity could establish a foothold here. Living on Mars carries risks that no amount of preparation can completely eliminate. Equipment failures, medical emergencies, accidents, all are more dangerous here where help is never immediately available and resources are always limited. The memorial reminds you that every person here accepts those risks, choosing to be part of something larger than individual survival, part of humanity's reach toward the stars. As you continue your walk, you spot a peculiar rock formation, ventifacts, rocks carved and shaped by wind-blown sand over millions of years. These wind-sculpted stones have smooth faces pointing into the prevailing wind and rough, irregular surfaces on their sheltered sides. They're like natural compasses, showing which direction the wind blows most consistently in this area. Mars's winds, though weak in force, have been working on the landscape for billions of years, and their effects are everywhere once you learn to recognize them. The planet is covered in wind streaks, dunes, ripples, and sculpted rocks, all evidence of an atmosphere that, though thin, is constantly moving, constantly shaping the world. Your communicator alerts you to something special. Tonight there will be a partial eclipse of the Sun by Phobos. These eclipses happen frequently on Mars because Phobos orbits so close to the planet and moves so quickly. Unlike Earth's moon, which can completely block the Sun, creating total solar eclipses, Phobos is too small to cover the Sun's disk entirely. Instead, it creates a partial eclipse, appearing as a dark oval shape passing across the Sun's face. The eclipse will last only about 30 seconds from start to finish because of Phobos's rapid orbital speed. Watching these frequent, brief eclipses is one of the unique experiences of living on Mars. A reminder that this is a different solar system configuration than the Earth-Moon system, with its own rhythms and patterns. You return to your habitat as twilight settles over the landscape. Inside, you remove your suit carefully, going through the decontamination procedures that have become second nature. Brushing off dust, checking seals, hanging everything in its proper place. The ritual of suiting up and unsuiting has become meditative, a daily reminder of the barrier between human life and the Martian environment. Tonight's dinner is special. The agricultural team has harvested the first tomatoes from a new strain they've been developing, bred specifically for Martian conditions. As you bite into the fresh tomato, its flavor bursting bright and alive on your tongue, you're overwhelmed with gratitude. This simple taste, this bit of freshness grown in alien soil, under an alien sky, represents everything humanity has achieved here. You think about Earth, where people pick tomatoes from garden plants without a second thought, where the air is free and the water abundant and the sun warm on bare skin. Part of you misses that world with an ache that never quite goes away. But another part of you, a growing part, knows that you're exactly where you belong. Here, where every tomato is a triumph, where every breath is a gift, where every sunrise over the rust-red desert is a reminder that humans can survive, can thrive, can make a home anywhere we dare to go. You wake earlier than usual today, drawn by something you can't quite name, a feeling, an instinct, a pull toward the observation dome. When you arrive, you find you're not alone. Several others have gathered here in the pre-dawn darkness, their faces illuminated by the soft glow of stars. Today marks a special celestial event. Mars is approaching perihelion, its closest point to the Sun. Though the difference isn't dramatic enough to see with the naked eye, everyone knows that over the next few weeks, Mars will receive its maximum solar energy for this Martian year, making this the warmest season. Though warm, on Mars is still bitterly cold by Earth standards. As dawn breaks with its familiar golden light, you head to the communications center for your shift. Today you'll be helping to coordinate with other colonies scattered across Mars. There are now several permanent settlements on the planet, some in the northern lowlands, others near the polar regions, a few in the ancient highlands. The total human population on Mars has grown to nearly 3,000 people, spread across multiple time zones on this world. Communication between colonies happens through a network of relay satellites and underground fiber optic cables being laid between major settlements. The goal is to create a planet-wide infrastructure, linking humanity's presence on Mars into a cohesive whole. During your shift, you review messages from the Polar Research Station. They're reporting unusual readings in the composition of the South Polar ice cap. While the North Polar cap is mostly water ice, the South Pole is more complex, a mix of water ice and frozen carbon dioxide or dry ice. In the Martian winter, temperatures at the South Pole can drop low enough that carbon dioxide freezes out of the atmosphere directly onto the ice cap. These seasonal deposits can be several feet thick, and when they sublimate in spring, they create fascinating features, geysers of CO2 gas erupting through the ice, carrying dark dust that creates distinctive spider-like patterns visible from orbit, features called araneoform terrain. After your shift, you join a geology class being taught by one of the senior scientists. She's explaining how Mars's internal structure differs from Earth's. Mars has a core made primarily of iron, nickel, and sulfur, with a radius of roughly 1,100 to 1,300 miles, about half the planet's total radius. Unlike Earth's core, which is partially liquid and generates our protective magnetic field, Mars's core appears to be mostly solid now, though some research suggests a thin liquid layer might remain. This cooling and solidification of the core billions of years ago is what doomed Mars's magnetic field and, ultimately, its thick atmosphere. Without that protective shield, solar wind gradually stripped away the atmosphere over hundreds of millions of years. The afternoon brings an excursion to inspect one of the colony's most important assets, the ISRU plant, the facility that processes Martian resources into usable materials. You watch as atmospheric processors pull in the thin Martian air, compress it, and separate out its components. The carbon dioxide is stored for various uses, including as a pressurizing gas and as feedstock for chemical reactions. Small amounts of nitrogen and argon are carefully extracted and stored. These gases are precious because they're needed for creating breathable air mixtures and for other life support functions. Mars's atmosphere is about 1.9% nitrogen and 1.9% argon, tiny fractions but essential for colony sustainability. While touring the facility, you learn about the water extraction systems. Several kilometers from the colony, autonomous mining robots are excavating subsurface ice from deposits that are about 80% water ice mixed with soil. This ice is billions of years old, frozen since ancient Mars lost its surface water. The robots heat the excavated material, capturing the water vapor and condensing it into liquid water that's then purified and transported to the colony. The process is energy-intensive, but it's far more efficient than shipping water from Earth. Each liter of water produced on Mars represents a liter that doesn't need to be launched through Earth's gravity well at enormous cost. As you return to the main habitat, you notice construction crews working on a new module. The colony is expanding, preparing for the next wave of arrivals. This new section will be partially constructed using Martian materials, bricks made from regolith, mixed with a polymer binding agent and sintered using solar concentrators. These bricks are surprisingly strong and provide excellent radiation shielding. Building with local materials isn't just practical, it's symbolic. Each structure built from Martian resources is a statement that humans aren't just visiting this planet, we're becoming part of it, literally incorporating Mars into our homes. Evening brings a community gathering in the main dome. Someone has set up a telescope and people are taking turns viewing celestial objects. You look through the eyepiece and see Jupiter, its bands clearly visible even through Mars's thin atmosphere. From Mars, Jupiter appears as a brilliant beacon in the sky, though not quite as bright as from Earth due to the greater distance. The four Galilean moons, Io, Europa, Ganymede, and Callisto, are easily visible as tiny points of light flanking the giant planet. Looking at Jupiter from Mars, you're reminded that you're now closer to the outer solar system than you are to Earth, a resident of the space between worlds. The gathering continues with music. Someone plays a guitar brought from Earth, and voices join in songs both old and new. There's a Martian anthem now, composed by a colonist, its lyrics speaking of red deserts and blue sunsets, of leaving one home to build another, of humanity's courage to reach beyond the cradle. As you sing along, you feel the bonds that tie this community together, forged not by proximity but by shared purpose and mutual dependence. Later, as the gathering disperses and people drift back to their quarters, you step outside for a final look at the night sky. The temperature has dropped precipitously. Your suit's external thermometer reads -90 degrees Fahrenheit. In this cold, carbon dioxide from your suit's exhaust would freeze instantly if it were released directly into the Martian air, forming tiny crystals of dry ice. The life support system is designed to prevent this, but it's a reminder of just how cold Mars truly is. Earth's coldest temperatures barely reach the average Martian day, and Martian nights are colder still. You look up at the stars, at the sweep of the Milky Way across the black sky, at Phobos racing overhead, at distant Earth hanging like a sapphire in the darkness. You think about the journey that brought you here, not just the physical journey of months in space, but the emotional journey of leaving everything familiar behind. There are moments when the loneliness feels overwhelming, when the isolation presses down like the thin Martian atmosphere, barely there but somehow still heavy. There are nights when you dream of Earth, of rain falling on leaves, of oceans stretching to the horizon, of breathing deep without a suit, of touching another person's hand without gloves between you. But there are other moments like this, when you feel privileged beyond measure to be here, to be witnessing this chapter of human history, to be one of the first people to call Mars home. Future generations will look back on you the way you look back on the first humans who crossed oceans, who settled new continents, who dared to go where no one had gone before. You are a pioneer. You are a bridge between worlds. You are proof that the human spirit can adapt to anything, survive anywhere, thrive in the most unlikely places. Tomorrow the work continues. There's always work on Mars, maintaining systems, growing food, conducting research, building infrastructure. But tonight, you rest beneath an alien sky, grateful for every breath, every heartbeat, every moment of this extraordinary life. Your final soul in this journey of discovery begins quietly, peacefully. You've been on Mars long enough now that the rhythms of this world have become your rhythms, the patterns of life here as natural as breathing. Today you'll be part of a special mission, traveling to an area where methane has been detected seeping from beneath the surface. Methane on Mars is one of the greatest mysteries, because this gas breaks down quickly under UV radiation. Its presence means something is actively producing it, either geological processes deep underground or, tantalizing as the thought may be, possibly biological activity. The methane appears seasonally and in specific locations, with concentrations varying from about 0.24 to 0.65 parts per billion in the atmosphere. As you prepare for the expedition, you reflect on how much has changed since humans first arrived on Mars. The early missions were purely exploratory, robots and then small crews conducting research and proving that survival was possible. Now, Mars is transitioning from exploration to colonization. There are children here now, born on Mars, who will grow up knowing Earth only through stories and videos. These first Martian-born children are closely monitored by medical teams, studying how human development proceeds in 38 centimos. So far, the children seem healthy, adapting remarkably well, though they'll need careful preparation if they ever want to visit Earth, where they'll weigh nearly 3 times as much and find every movement exhausting. The rover journey takes you through an area of ancient lava flows, their surfaces frozen in mid-flow for hundreds of millions of years. Mars's last volcanic activity probably occurred somewhere between 2 and 10 million years ago, relatively recent in geological terms. Some scientists believe that volcanic activity might still occur occasionally, that Mars isn't completely geologically dead, just dormant. If active volcanism does continue, it would be incredibly significant for potential habitability, providing heat sources and possibly creating environments where liquid water could exist in underground pockets, perhaps even supporting microbial life forms in Mars's deep subsurface. You arrive at the methane detection site, where instruments have been monitoring gas emissions from a small vent in the ground. As the team sets up equipment, a geochemist explains that Mars's methane mystery is complicated by the planet's unique atmospheric chemistry. The thin atmosphere allows methane to be destroyed more quickly than on Earth, yet it keeps appearing. If the source were ancient methane trapped in ice deposits and slowly releasing, it should show a steady, constant level. Instead, the methane appears in plumes, suggesting active release from specific sources. The leading geological explanation involves water reacting with iron-rich rocks deep underground in a process called serpentinization, which can produce methane without any biology involved. While the instruments collect data, you take a moment to explore the immediate area. You find small nodules in the soil, concretions formed by mineral-rich water percolating through rock over long periods. These concretions, sometimes called blueberries because of the blue-gray color some exhibit, are made primarily of hematite, a form of iron oxide. They're evidence of groundwater activity in Mars's ancient past. The soil here, like everywhere on Mars, is slightly alkaline with a pH of about 8 to 9, less hostile to life than the acidic conditions once suspected. This moderate pH, combined with evidence of ancient water and essential chemical elements, means Mars once had conditions that could have supported life, even if we haven't found definitive proof yet. As afternoon arrives, you share a meal with the team inside the pressurized rover. Someone mentions that a supply ship from Earth is scheduled to arrive next month, and with it will come more colonists, engineers, scientists, artists, teachers, all bringing their skills and dreams to Mars. The colony is expecting its population to double within 5 years. Plans are being drawn for larger habitats, for extensive tunnel systems connecting different settlements, for eventually terraforming small enclosed areas to create shirt-sleeve environments where people can live without suits. The dream is growing, evolving from mere survival to genuine civilization. After lunch, the team leader shows you data from the seismic monitoring network. Over the past year, sensors have detected over 450 Marsquakes, most too small to feel but revealing incredible details about Mars's interior structure. The data shows that Mars's crust is thicker than Earth's relative to the planet's size, averaging about 15 to 45 miles thick depending on location, compared to Earth's 3 to 25 miles. This thick crust is part of why Mars cooled more quickly than Earth and lost its geological activity. Heat from the interior has a harder time reaching the surface, volcanic activity diminished, the core cooled and solidified, and the planet entered its current dormant state. As you begin the journey back to the colony, the sky begins to change. A dust storm is developing on the horizon, not a major one, but enough to color the sky a deeper orange and create a hazy glow around the setting sun. These smaller storms typically last a few days, reducing solar panel efficiency temporarily and coating everything in a fresh layer of dust. The colony's weather prediction models, trained on years of Martian meteorological data, have become quite accurate at forecasting these events, allowing preparation time. Still, Martian weather retains an element of unpredictability, a reminder that this planet still holds mysteries, still has secrets to reveal. As the sun descends, you witness one of Mars's most beautiful phenomena: crepuscular rays, beams of sunlight streaming through valleys and distant mountains, made visible by dust in the atmosphere. These rays are the same phenomenon you'd see on Earth, but here they appear golden-orange against the peachy sky, creating an otherworldly beauty that never fails to move you. You stop the rover for a moment, and everyone simply watches in silence as the Martian sunset unfolds, painting the sky in layers of color: purple at the sun, fading to pink, then orange, then the butterscotch yellow of the day sky. You arrive back at the colony as the stars begin to emerge. Inside, you go through the familiar decontamination routine, then make your way to the common area where dinner is being served. Tonight's meal includes fresh lettuce and herbs from the greenhouse, protein from cultured cells grown in bioreactors, and bread made from wheat cultivated in Martian soil. It's not fancy by Earth standards, but it's entirely produced here on Mars. A complete meal grown 140 million miles from Earth, a small miracle of human ingenuity and determination. After dinner, you climb to the observation dome one last time and look out over the Martian landscape. The colony's lights glow warmly behind you, but ahead stretches the endless desert, the ancient plains, the distant mountains sharp against the star-filled sky. Phobos rises in the west, beginning its rapid journey across the heavens. Deimos hangs motionless, a faint star among thousands. You think about the 100 facts you've learned, the 100 truths about life on Mars. The gravity that makes you feel light. The sky that glows butterscotch by day and displays the universe in all its glory by night. The water locked in ancient ice. The dust that covers everything. The temperatures that swing wildly from day to night. The thin atmosphere that can't sustain human life but creates the most beautiful sunsets. The two small moons racing overhead. The endless desert that was once covered in water. The challenges and the triumphs, the loneliness and the community, the sacrifices and the rewards. Life on Mars is hard. It demands everything from you: your attention, your effort, your courage, your resilience. Every day presents challenges that would have seemed impossible just generations ago. Every breath comes from a machine. Every drop of water is recycled. Every vegetable is a victory. Every moment outside requires a spacesuit between you and instant death. But life on Mars is also extraordinary. It's a front-row seat to humanity's greatest adventure. It's watching our species become multiplanetary, spreading beyond the cradle of Earth to establish ourselves among the stars. It's being part of something so much larger than yourself that individual concerns fade into insignificance. It's knowing that thousands of years from now, when humans have spread throughout the solar system and perhaps beyond, they'll look back at this moment, at these first colonies, at these first pioneers, with wonder and gratitude. You are writing the first chapter of humanity's story as a spacefaring civilization. You are proving that we can adapt, that we can survive, that we can thrive anywhere we have the courage to go. As you stand there beneath the Martian sky, watching Phobos race westward and the stars will slowly overhead, you feel a profound sense of peace, of purpose, of belonging. This red planet, this harsh and beautiful world, has become your home. Not in spite of its challenges but because of them. Not because it's easy but because it's worth it. Tomorrow you'll wake to another Martian dawn. You'll work and explore and discover and build. You'll face new challenges and find new wonders. You'll laugh with friends and dream of the future and remember Earth with bittersweet fondness. But tonight, you simply rest, grateful for this extraordinary life, for this chance to be part of humanity's reach toward infinity, for every breath, every heartbeat, every moment under an alien sky. Welcome home. Welcome to Mars. Welcome to the future. May your dreams carry you across red deserts under butterscotch skies, and may you wake to find wonder in every new soul.